In this question, number 8 on the Chapter 19 homework, you're given a redox reaction and we're asked to calculate the standard voltage. Well, based on the reaction as it's written, lead is oxidized and magnesium 2 plus is reduced. So this is the anode, or the lead is the anode, and the magnesium is the cathode. And when you look up those numbers and do cathode minus anode, you get a negative value. I think it's negative 2.24 or something like that, but it's negative. Now, that tells you that it's not or non-spontaneous. The next part of the question says, select all that apply for the reaction running in the spontaneous direction. So the spontaneous direction is the reverse direction. So let's just rewrite the reaction. We'll have Mg solid plus lead ion going to magnesium ion plus lead solid. So what we will have is magnesium being oxidized, and it's the actual magnesium solid that's oxidized, and we have the lead 2 plus ion that is reduced. So in this reaction, magnesium 2 plus is created and Pb2 plus is used up or used. Alright, so let's go through our options here. Pb2 plus is the substance being reduced. Yes. Magnesium 2 plus is the substance being reduced. No. Lead is the substance being oxidized. No. Magnesium is the substance being oxidized. Yes. The forward reaction is spontaneous. No, we've already determined that the reverse reaction is spontaneous. Electrons will flow. Alright, let's look at electron flow. Electrons flow from anode to cathode. And that's because oxidation happens to the magnesium and flows over to the lead. The substance that's oxidized loses electrons, which travel over to the other electrode. So magnesium is losing. So electrons will not flow from the Pb electron. They flow from the magnesium half cell to the lead half cell. And the concentrations, we have determined that lead is used up, so that means it's decreased. So it won't increase, it will decrease. And we determined that magnesium plus 2 is created, so that means its concentration increases. And they don't remain constant.